All right, welcome to Next Gen Manufacturing. When we think about shaping metal, it's easy to picture just brute force. But honestly, modern machining is a whole different ballgame. It's all about intelligence, about strategy, and it's about finesse. Today, we're going to dive into a technique that just perfectly captures this whole shift, a much smarter way to make that very first cut.
So let me just ask you this. In the entire process of milling a part, from start to finish, what do you think is the single toughest, most brutal moment for a cutting tool? It's probably not what you're thinking. It's not in the middle of a long cut. It's not during the finishing pass. Nope. It's something way quicker and a whole lot more violent.
It's that very first moment of contact. Seriously, just picture it. A cutting tool spinning at thousands of RPM, and it just slams straight down into a solid piece of material. The industry has a name for this, shock loading, and yeah, it's just as punishing as it sounds. This one single high-impact moment is one of the biggest reasons for premature tool failure, and it costs shops a ton of time and money. But what if you could just avoid that violent collision altogether? Well, you can, and that's where this brilliant technique called ramping comes in. Instead of plunging straight down, ramping is this elegant solution where the tool enters the material at an angle. It's moving down and sideways at the same time, kind of easing into the cut instead of smashing into it. It's really the difference between jumping off a high ledge and just walking down a ramp.
Okay, so once you decide to ramp, there are two main ways you can go. It's not just about going in at an angle, it's really about the shape of that path. And believe me, that shape makes all the difference in the world. So on one hand, you've got linear ramping. I want you to think of this like walking straight down a really steep hill. It gets the job done, sure, but it's still putting a lot of side pressure, what we call radial engagement, on that tool. It's viable, but it's stressful for the cutter. But on the other hand, we have circular ramping, which is also called helical interpolation. Now this is the recommended method. This is like taking a nice, gentle, winding path down that same hill. By using all three axes in a spiral motion, it spreads out all those cutting forces, which drastically cuts down the stress on the tool. And that means you get the longest possible tool life.
And here's the most important part. This isn't just some fancy technique for its own sake. Choosing to ramp has real, tangible benefits that go straight to the bottom line. It's really all about working smarter so you can get results that are faster and, yep, cheaper.
And what's really cool is how all the benefits start to stack up. First off, you completely eliminate that damaging shock loading we talked about. That means you're going to have way less costly tool breakage. And because you're easing into the cut, you make smaller, much more manageable chips that are super easy to clear away. Better chip evacuation means you can run the machine faster, which cuts down your overall cycle time. Oh, and here's a fantastic bonus. Since you don't need a separate drill to create a starter hole, you free up a valuable spot in your tool changer. It's a win on absolutely every front.
And look, this isn't just some theoretical idea. Machinists have real-world established parameters for this stuff. The angle you use to ramp in actually changes depending on the material. So for softer stuff like aluminum, you can be a bit more aggressive, maybe between 3 and 10 degrees. But for tougher, ferrous materials like steel, you need a much gentler entry. Somewhere between 1 and 3 degrees is best. It just goes to show how this whole strategy gets adapted for every single situation.
Ramping isn't just an isolated trick. It's really part of a much bigger idea in modern manufacturing. You could almost call it a philosophy of intelligent tool entry. It's all about thinking strategically about every single move a machine makes.
And a perfect example of this philosophy is a technique called arcing. Think of it like a cousin to ramping. While ramping is for entering a part from the top down, arcing is for entering from the side. So instead of moving straight into the workpiece, the tool follows a curved path to ease in. Again, it gradually increases the load on a tool, avoids that shock, and preserves its life. It's the exact same intelligent principle, just applied from a different direction.
And that really brings us to the big question, doesn't it? We've seen how just one simple change in approach, entering at an angle instead of just plunging straight in, can have this huge ripple effect on efficiency, on cost, on tool life, everything. So if one smart move can totally revolutionize a single cut, what does that tell you about the future? What other simple, intelligent shifts are just waiting out there to completely redefine the world of next-generation manufacturing? That's something to think about.